Okay, so this is a Ka and pH calculation. I'm going to start with what is meant by weak acid and Bronsted-Lowry acid. Well, Bronsted-Lowry acid just means it's a proton donor, so it's going to give off H pluses. A weak acid means it partially dissociates, so it doesn't fully dissociate. And then you need both of those for the mark. Then we're going to calculate the pH of a 0.5 mole decimeter cube solution of potassium hydroxide. So this is HANA hydroxide. You need to know that Kw equals H plus times OH minus. Kw is 1 times 10 to the minus 14. H plus we don't know. OH is 0.5, which gives us 2 times 10 to the minus 14 for the concentration of H plus. If we minus log of this, we get 13.7 for the pH, because pH is minus log of the concentration of H plus ions. Then we've got ethanoic acid here. We want a Ka expression. That's going to be C2H5COO. Oh, it's propanoic acid, not ethanoic, sorry. Times H plus the proton that's dissociated over the concentration of propanoic acid itself. Calculate the pH of this diluted solution. Well, we've got in this, it was originally 0.48 in 25. It's been diluted down by 4 up to 100. So the new concentration of the propanoic acid is going to be 0.12 mole per decimeter cubed. We're diluting it down by 4. We now know that the Ka, got told it right at the start, is 1.35 times 10 to the minus 5. It's going to be H plus squared, because both these are the same, over 0.12. So rearranging this, I'm going to get the concentration of H plus equals the square root, because I had it squared, now I don't, of 1.35 times 10 to the minus 5 times 0.12. And that is going to give me a concentration of 1.27 times 10 to the minus 3 for the concentration of the H plus ions. Now I know the concentration of the H plus ions. I can do the same thing I did up here and do minus log of 1.27 times 10 to the minus 3, and that gives me a pH equal to 2.9 for that solution.